Welcome back. This is the second video recording for the lesson we did on the week 2 of IM2. Okay, so the second goal is to be able to sketch quadratic graphs really quickly. So I am going to demonstrate using these two equations. For those of you who did homework, you should be all very familiar with this already. You should be very good at it by this point. Just to recall, the three steps involved in sketching: you find x, y, x-intercepts, y-intercepts, and vertex, because those are the three key points that will be helpful for you to be able to sketch them. Then you plot those points and then draw a parabola that goes through all of them. So let's begin by demonstrating that. So the first problem I am going to demonstrate is y is 3 times x plus 4 all squared minus 12. Now this is in vertex form. That means the vertex is very easily identifiable. It's the opposite of the number in front inside the parentheses. That's the x value. So the vertex, my vertex is going to be -4, and the y value is this number here, -12. Okay, and then from here, now we need to try to find x-intercept. Let's try x-intercept. How do we find x-intercept? Remember, x-intercepts always have some number, comma 0. That means the y value is always 0. So we're going to set the y to be 0 times x plus 4 from the original equation. I'm going to bring the -12 to the other side by adding 12. And then divide both sides by 3 to cancel this out. And now you're left with 4 is equal to x plus 4 all squared. Now from here, I am going to take square root of both sides. Remember, this is solving by square rooting method. That leaves me with x plus 4 is plus or square root of 4 is 2, so plus or minus 2. That means x plus 4 is plus 2, or x plus 4 is -2. So from here, subtract 4 from both sides, x is -2, or x is subtract 4, that's going to be -6. So my intercepts are, x-intercepts are -2, 0, and -6, 0. Okay, now let's look for the y-intercept. Y-intercept. Remember, with y-intercept always has 0 as the x value and then followed by some number. So to the original equation, I am going to substitute x to be 0. So y is 3 times x, which is 0 plus 4 all squared minus 12. So 0 plus 4 is going to be 4 squared, which is 16, times 3, 6. So that's going to be 3 times 16. Minus 12, that's going to be 54 minus 12, which is 42. So my y-intercept is 42, 0. Okay, now we have found the vertex, the x-intercepts, and the y-intercept. So let's plot them at this point. I am going to start by drawing a quick sketch of x and y axis. That's my x, that's my y. And then from here, I am going to put in my x-intercept, so -2 and -6. So that's -2, -4. Let's call this -6. And I need to find my vertex. It's -4 and -12. -12. Okay, so let's call this, let's call this -12 here. So that's going to be -6. So that's going to be +12, 24, 36. So 42 is going to be yet another 6 from here. That's 42 here. So that's going to be my 1 point here, another point here, another point here, and another point here. And now that I've done plot those points, I know that parabola is going to be symmetrical. So draw a nice curve that connects this. Okay, and that's my parabola. Great. I am going to show you another example. So y is negative 1/3 times x minus 3 all squared plus 12. Okay, same process. What is the vertex? It's really easy to find. It's this number because it's already negative 3. So that's going to be opposite of the number inside the parentheses, 3, comma, 12. So the x-intercept, we are going to set y to be 0. So 0 is equal to 1/3 times x minus 3 all squared plus 12. Bring, this time I can bring 12 to the other side. So negative 12 is equal to negative 1/3 x minus 3 all squared. I am just going to multiply both sides by positive, so that becomes positive, positive. Now, to get rid of this 1/3, I am going to multiply both sides by 3. So that leaves me with this cancels out. And 3 times positive 12 is 36, is equal to x minus 3 all squared. And take a square root of both sides. Don't forget to put plus or minus when you do that. Leaves me with x minus 3 is equal to plus or minus 6. So x minus 3 is equal to 6. So x minus 3 is equal to negative 6. So add 3 to both sides. So x is 9 or x is negative 3. So my x-intercepts are 9, 0 and 3, 0. Those are my x-intercepts. Okay, now y-intercept. For y-intercept, we're going to set x to be 0. So y is equal to negative 1/3. X is 0 minus 3 all squared plus 12. Negative 1/3 times, that's going to be negative 0 minus 3. So negative 3 all squared is positive 9 plus 12. 9 times 1/3, negative 1/3 is going to be negative 3. Negative 3 plus 12, which is same as positive 9. So y is 9. That means the y-intercept is going to be 0, 9. Okay, so now that we've figured out all the points, we can find those points on the graph. We want the x-intercepts to be, I'm sorry, I made a mistake here, negative 3 and positive 9. So if this is 3, there will be about 3, 6, and 9 here. So we know that this is a point here, this is another point, those are my x-intercept. Vertex was positive 3 and positive 12. Okay, positive 12, let's just mark this as 2, 4, 6, 8, 10, 12. Let's call this 12 here. So 3, 12 is going to be right here. And then followed by the y-intercept we found to be 0, 9. So that's going to be 9 will be here. And again, this is my vertex, so it's going to be symmetrical from here. And of course, the equation is opening down because the a value is negative 1/3 here. Great. So let me stop it right there. Okay, now it's time for you to try graphing these two quadratic equations in vertex form. Please pause the video and try this yourself. The answer will be shown in 5 seconds. 5, 4, 3, 2, 1. Great. How did you do? That's the first graph, what it should look like. The vertex is 4, negative 2. X-intercept is 2, 0, 6, 0, and the y-intercept is 0, 6. And again, it should be symmetrical kind of looking parabola, and then the second graph should look like this: -3, 8 as the vertex, -5, 0, -1, 0 as the x-intercept, and 0, -10 as the y-intercept. Great, I'm going to stop it right here for the second recording, and I'll get started with the third recording.